Howdy, yo, homie. How you doing? Thank you so much for letting me know. Yo. Is there audio on both? Awesome. Nice, man. Dude, this is probably the first time you guys are seeing me in a shirt, a proper shirt, because I have a meeting just after this. I have a very hard stop at 8 a.m. because I have a meeting with the client. Hopefully things work well. Let's see. Oh, thank you. I'm not much of a shirt guy though. I don't know why. I like it when I'm wearing a blazer or like a proper formal event, but usually at home, not my thing. Okay, ready to get started with some networking concepts. I was thinking like there must be more people today because it's been some time, or maybe that's why. What are you making for food right now? Key. Radhe. Howdy. Okay. Let's focus on our networking concepts back again. I don't know why I think last time we completed. Oh, we didn't complete all the layers, right? We talked about the networking layer. We were talking about how, just like in your maps, when you are like want to go from point A to point B, there is like various routes, but best one is based on, let's say, the time, right? If you want to go with distance, might be a different one or same one. But let's say there is one, the best one being the shortest time one. Same thing happens with the networking packets, right? So now let's talk about the transport layer, session layer, presentation layer, and the application layer, and complete at least this task so we can move on to the networking, like complete more on the networking basics. Moreover, tomorrow I don't have a meeting early in the morning at 6 a.m. So we can start around like that time for streaming, and that would like help in like covering more of this networking basics. But okay, let's get started with layer 4 transport layer. And let me get my, so I can draw things. Okay, here we were talking about various IP addresses and stuff. Okay, transport layer. Layer 4, the transport layer, enables end-to-end communication between running application on different hosts. This is like, let's say if you're using a phone, right? Right now, there is a communication happening between me and you guys through YouTube, Twitch, any kind of streaming, or WhatsApp is one, right? There are various ways. So end-to-end communication between running applications on different hosts, different machines. So that's what transport layer does. Your web browser is connected to TryHackMe web server over the transport layer. Yo, Ghost, what's up, bro? Howdy, man. How's everything going? So your web browser is connected to the TryHackMe web server. There is a communication between happening your browser and your server over the transport layer, which can support various functions like flow control, segmentation, and error correction. So what does flow control? How things are flowing, how's the communication happening, how we can divide all the information right in different small packages and all those stuff. And also error correction in the sense, let's say if I send data, somehow the data got corrupted, somebody in the man in the middle attack is happening where somebody tries to manipulate the data, that also is done. All good. I'm deep into GitHub Actions, making bug bounty automation in there. Oh, nice. That's awesome, man. That's awesome. Dude, that looks like a fun project indeed. Awesome. So examples of layer 4 are TCP protocol and UDP protocol. Now, important for majority of the people to understand what is going on, right? A lot of people don't realize TCP and UDP are layer 4. IP is layer 3, right? Where it is? Here. IP is layer 3, which is about addressing, right? Layer 3 about the addresses of your computer on the internet. What is your address? Routing, like exactly like how, like routing is also layer 3, but like how, what protocol to use while sending data, right? That error checking, all those stuff, and segmenting them, dividing them properly into smaller packages and transferring them over the network, that's layer 4, right? So flow control, segmentation, error checking, that's TCP or UDP. Layer 5, session layer. So sorry, just to confirm, layer 3 is about addresses, right? If you guys can see, layer 3 is about addresses, helping with like the routing and stuff too, because you need address to route things. But like how the package itself is going, what is the coverage, what is the layer for security, that's layer 4. Next, layer 5, session layer. The session layer is responsible for establishing, maintaining, and synchronizing communication between applications running on different hosts. Establishing a session means initiating communication between applications and negotiating the necessary parameters for the session. Data synchronization ensures that the data is transmitted in the correct order and provides mechanism for recovery in case of transmission failure. So, keeps initiating communication. So this is what, when you are, let's say, on Amazon, right? You don't have to keep on logging in again and again, right? Or like on Facebook, on YouTube, right? Because there is a session for a time being, right? That they know, okay, it's you in your Amazon account. You can go whatever you want to do. There's a session. They have already done all the negotiation. Moreover, right, when the session expires, that's where we need to go again on the session layer, right? So session basically waits so that you don't have to keep on communicating again, or like keep on logging in again and again. Data synchronization ensures that data is transmitted in the correct order and provides a mechanism to recovery in case of transition failure. So again, like checking if there is any case of failure, you can do again. Same thing, like there is security app heavy, like error correction is here. IP, I believe, might have some error correction. There's like at least security protocols are here as well with the VPN. So security happens at every single layer. Examples of session layer are network file system, NFS, and remote procedure call, RPC. This actually, like, you might know RPC, right? You guys have used it. There is one. Yeah, remote procedure call. I believe there is an application which I think a lot of people use. Allows program to execute a function from a remote computer as it is very local. Yeah. So RDP is a core technology. So RDP and RPC are very similar, I guess. Maybe. Okay, I will look into this more. But yeah, RPC is the one. So remote procedure call. Networking file system for sessions, basically establishing a communication. What's up, Rover? A very good morning to you, boss. Now, let's talk about the presentation layer. This is, I think, application layer is, you will understand what presentation layer is, but you might get confused with application, so we'll spend a little bit more time on this. Yo, Shriram, what's up, bro? Howdy, howdy. So the presentation layer ensures that data is delivered in a form or in a form the application layer can understand. So data is being sent in form that your browser can understand. Layer 6 handles data encoding, compression and encryption. An example of encoding is character encoding such as ASCII or Unicode. Now let me show you something interesting. This is OBS, which is what I use for streaming, right? If you look at the output, video encoder, there's audio encoder. These encodings are probably are for presentation, right? How things will be compressed and coded, whatever I'm doing, and being sent to your browser. Various standards are used at the presentation layer. Consider a scenario where we want to send an image via email, right? First, we use JPEG, GIF, PNG, whatever is the format we want to use for our image to save our images. Furthermore, although hidden from the user by the email client, we use MIME, multi-purpose internet mail extension, to attach file to our email. MIM encodes a binary file into 7-bit ASCII character. So all the data is actually binary, right? Like zeros and ones. I hope everybody by now knows this, right? Every single thing on computer is zeros and one. Now it's being encoded. So let's look maybe what happens if there is a good image. Okay. Let's see here. So you are the sender, right? You want to send an image or whatever to your client, to your friend, right? User agent, basically your Chrome, Google Chrome, Internet Explorer, the OG or anything, right? Goes through MIM. It is encoded. Your image is encoded, your video is encoded, everything is encoded. Message transfer agent, the email server. Let's say if you're using Outlook, goes to Gmail, which is your friend's. MIM, user agent received. Same thing. That's like what happens. An ASCII code. So all the bits becomes A, B, C, like we talked about last time. So it's easy to transfer data, basically. Layer 7 application layer. The application layer provides network services directly to end user applications. So HTTPS, what your browser you see, that's application layer. Your web browser would use the HTTP protocol to request a file, submit a form, or upload a file. I think FTP is at this level as well. Yeah, FTP is also an application where you're sending and receiving files from a server. YouTube happening is also at this level. Maybe VNC. This is one of those layers where you will spend more time. The 3 layers you spend more time on compared to others is layer 7, layer 3 and layer 4. Because a lot of application, a lot of like networking is happening at those levels. The application layer is the top layer. Application layer is the top layer, and you might have encountered many of the protocols as you use different applications like HTTP, FTP, DNS. We talked about POP3, SMTP, and IMAP. Don't worry if you are not familiar with all of them. We will cover. But HTTP is basically how you see things on your browser. Summary. Reading about the ISO or OSI model for the first time can be intimidating. However, it becomes easier as you progress in your study for networking protocols. To help with your studies, we have summarized the ISO OSI model in the above table. ISO, remember, the Organization for International Standards. OSI, this thing. Provide services and interface, data encoding and encryption, establishing and maintaining a session, end-to-end communication, addressing like internet addressing, and routing. This is where like these are the two where you spend a lot of your time. And also this guy. Reliable data transfer, physical data, blah blah blah. Okay, now let's do a quick quiz, and I want your guys' participation. Are you guys ready? I want a yo, hell yeah, something from you guys. Ready? Hell yeah, nice. Thanks, Rover. Okay, so let's see which layer is responsible for end-to-end communication between running applications. Give me the layer number. Layer 4. Hell yeah. Good job, Shriram. Thank you, thank you. So, which layer is responsible for routing packets to the proper network? You have a package, you want to send to your friend. What was the protocol we were talking about regarding addresses and routing? What was the layer? I'll say. Layer 3, yes sir. In the OSI model, which, yes sir, yeah, thank you Ghost, thank you Shinam. In the OSI model, which layer is responsible for encoding the application data? This is where I showed you the OBS setup of mine, where I was talking about encoding and stuff. So, let's hear it. Yes sir, yes, 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 thank you. Next, which layer is responsible for transferring data between hosts? Yes, Shriram, 6. Which layer is responsible for transferring data between host and the same network segment? Yes, sir. This is where we talked about when, let's say, inside a room you want to share internet, right? This would be an easy one. Now let's see the time. Okay, hopefully we can cover, because I have a very hard stop at 7:55 for work. That's why you see this t-shirt, this shirt on for the first time, I guess. Okay, TCP IP model, right? Now we talked about the OSI model. What is different? What's going on with the TCP IP model? To summarize, TCP IP model is same as OSI model. It's just certain layers are being converted or like being put together because of their functionalities were so similar. They were like, okay, together. Like for example, we are talking about apples, oranges, bananas, right? What the that's what OSI model is. Fewer layers combined. Yes. So we've talked about apples and oranges, right? Instead of like saying apple and orange, TCP model does is say fruits. That's the concept. Basically, everything is same. It's just how they say it together, right? So, now that we have covered the conceptual ISO OSI model, it is time to study an implemented model. The TCP model, a TCP IP model, right? The TCP IP model stands for Transmission Control Protocol and the Internet Protocol, and was developed in the 1970s by the Department of Defense. I hear you ask why DoD would create such a model. One of the strengths of this model is that it allows a network to continue to function as parts of it are out of service. For instance, due to a military attack. This capability is possible in part due to the design of the routing protocols to adapt as the network topology changes. What does this mean, right? let's say when you are going from point A to point B with Google Maps, right? One, you see, okay, one of the routes is like there is a blockage, you can't go, right? Your current route, you can't go. What it does, it reroutes you to another path, right? The best path possible if this path is gone. That's what they're talking about. It allows network to continue to function as parts of it are out of service, right? Let's say if your data here, let's say because of some military attack happened, right? And this part, this route is not available. Howdy Panda, a very good evening to you or good morning. So route 1 is not available. Then this model says, hey, route 1 is not available, no problem. Let me find you the next best one, and it does this one, let's say, right? This is your new path. And that's what this layers, even like OSI model does the same, because they both are actually the same thing. It's just how they say things. So in our presentation of the ISO OSI model, we went from bottom to top. Layer 1, we did bottoms up. So layer 1 to layer 7. In this task, let's look at things from a different perspective, from top to bottom. Yo, Ido, what's up? From top to bottom, we have application layer, the OSI model application, presentation and session layer. So layer 5, 7, 5, 6, 5, 7, 5, 6, 7. Sorry. So 5, 6, 7 are grouped into application layer. Layer 4 is transport layer, same. Layer internet protocol layer is layer 3, same as the OSI model, right? Link layer, this is layer 2. Should also mention about 1, but okay. But if I want to give you guys a good image, and OSI. Here is how things look. Oh, this is it. This is a simple idea to show what's going on, right? Application, presentation, session, all into application, transport, network. Data link layer and physical layer become network access layer. Even they don't mention this, but basically because you still need copper wires, right? How will the communication happen? So it's part of the link layer, data link layer. Okay. Many modern networking textbooks show the TCP/IP model as 5-layer instead of 4. For example, in computer networking, a top-down approach, 8th edition, could describe the following 5-layer internet protocol stack by including the physical layer. What's that? Yeah, exams after exams, actually dark version of school. Colleges, in Indian colleges are like that, bro. Yeah, it's funny you mentioned about colleges and exams. My 4 years in my university, every single year there was an exam on my birthday. 3rd October, every single year there was an exam on my birthday. Could not even sleep properly that day, man. It is like you have put it the best way. Darker version of school. It is the best description of colleges, I guess, sometimes. Especially nowadays. Okay, going back. Describe the following 5-layer protocol stack by including the physical layer. Application, transport, network, link, and physical. In the following task, we will cover the IP protocol from the internet layer and the UDP and TCP from the transport layer, right? September 18 midterm exams. Yeah, man. At least we share some good pain together. It's fun. Answer the questions below. To which layer does HTTP belong in the TCP IP model? What is the name of the layer? Next, how many layers from the OSI model does the application layer in the TCP IP model cover? In the name of the party that used to ask how was your exam. In the layer 5, yes, but is the name right? Let's see. Layer. Think about what is the name of the last layer in TCP/IP model. It is the same as the OSI model. Give it a try again, Shira. Let's go. You got this. Yes, sir. Application layer. If you remember this one, remember this. Yeah. Because in TCP, there is no presentation or session layer. It's all application layer. Yeah. All good. You're learning. I think this is good. Like, at least if you're learning these things in your first year, you are way far ahead than majority of the people. Next, how many layers of the OSI model does the application layer in TCP/IP model cover? How many layers are in the OSI model are covered in TCP/IP? I believe it's not asking how many of them are grouped together. Is it? I think it's asking like all. Either it should be cover. Oh, like maybe cover that way. Okay, sounds good. I thought it's asking for like covers. I'm like, it covers all 7, honestly. Yeah, he's learning outside. Yeah, yeah. That actually is really good. Like for him, it's asking for the group. Oh, I see. I see. I see. How many of them are grouped together? Yeah. Like, or basically gets hidden. It's my bad. I'm still struggling with English, man. I'm still struggling with English in this country. Okay, lads. I think we are very much near to the end of today's stream because of the constraint I have. Let's have a look. Because good part is tomorrow I don't have a meeting. It's just at 8 a.m. my time. So the morning one is not there. We can start around 6:30 a.m. my time. What is the time right? What's the time right now in India? This. There's UDP, TCP. It's 9:17 right now. 9:18. Okay. So 1.5 hour difference. There is something called daylight saving in Canada where like the time changes. So earlier there was only like if for me if it is 8:20 for you it would be like something like 8:50 for me. Now it's 7:50 for me. That's like a very interesting and stupid concept, obviously. Daylight saving. These guys change the timing. They change the day time by 1 hour. Yeah, college syllabus sucks. I don't have any idea why I'm studying about building and welding and calculus. But welding is fun. Yeah? Yeah, it is stupid. Yeah, no, 100%, man. Like, this daylight saving is stupid. First time I heard about it, I'm like, this is the most weird thing in this world. And interestingly, a lot of people like are not able to get proper sleep, and it leads to a lot of deaths. I think I saw a study, so it's very interesting. They still let it go. Welcome to engineering, yeah. Welding might be fun. At least you learn something handy, helpful in the world. But like learning calculus in college, maybe just first semester, sure. Right, first semester sure because AI still like involves a lot of maths, but like after first semester I don't think anybody should learn calculus, especially not in college. If you're not, I live in Bangalore and not from here. Oh, nice, yeah, yeah. We use like it's all AI. Yeah, makes sense. Dude, computer application is a good one to join indeed. Yeah. Python.maths is way more than enough. Yeah. It's very interesting. It's very interesting what like colleges ask when like, but like the worst part about colleges, like you actually trust them that okay, calculus might be important, this might be important, but you actually when you need help, things like they never come back to help you. These institutions never come back. Yeah, 100%. It's all BS, man. I'm a commerce graduate and now a senior networking engineer. Nice, bro. Yeah, that's amazing. That's so good. Yo, do you have Ghost? Do you have CCNA and stuff? You must be like you must have like a bunch of Cisco network, like those things, right? Okay, lads. I think I got a bunch of messages on my Teams, so I have to go now because it was my dream when I was in 10th standard. Now I'm struggling to do. Dude, it's crazy, man. How adulthood and like these things, CCNA, CCNP, CEH, yada yada yada. Oh, nice. That's awesome. Dude, network engineer is like one of those jobs. If you have CCNA, you have like so much job opportunities even when the time is down. So it's really good you have that, man. I need to get some certification so I can get jobs. Simple. Yeah, it's interesting. But you know what? That's fine, whatever it is. I will like get some certificate. I want to complete my PT1 this year, or actually next year in the first quarter. But good part is for you guys, right? Tomorrow, I don't have any morning ones, so it's 6:30 my time. So I think it will be then 8 p.m. for you guys. Oh, OSCP, nice. So tomorrow 8 p.m. I will come online till 9:30 because I won't have any super hard stops tomorrow. And then on Tuesday, next Tuesday is a holiday for me. So good part is I can go like it's a remembrance day, remembering the soldiers who gave their life. But like because it's a holiday, we will go for a very long day. Be prepared. Your Tuesday evening, we will do at least like 3 hour long stream. 3 hour long stream, and we will cover so much more topic. But tomorrow, at least because we have 1.5 hours, we can cover this task IP addresses one. Then we can cover. This is a big one, so I will try to prepare early. UDP and TCP, we can cover tomorrow. And hopefully we can cover encapsulation and telnet. We can cover all these four tomorrow in 1.5 hours. And yeah, let's see how things go. But after that, after these networking concepts, and on Tuesday, I think we will be in a position to cover after networking concepts. It would be networking essentials and networking core protocols. Those two will be done next week. Okay. Okay, let's have a hard stop. Sorry, I have to leave early this week. It's just trying to find projects in my company so I don't get fired, and just talking to clients and all these meetings, yada yada yada. But thank you so much for all the chats. Hope you guys have a great night, great day, and thank you so much, man. Thank you. It's just like this is this. Yeah, firing is everywhere, man. It's like crazy. We are in a recession at this point. Like we are very close to a recession. So save your money. keep the cash handy. You might be able to win big. Thank you so much, lads. Thank you so much. But yeah, as I was saying, it's my main bread and butter, right? Right now, my full-time job. Once I become a bigger streamer, so then it would be like longer streams every day. I promise. More fun stream, more longer stream, more giveaways. Hopefully, I can hire other people. So, keeping what's this called? Fingers crossed. So, thank you, lads. Have a good one. This is your favorite neighborhood sniffer of packets. Your favorite friendly neighborhood. No, not Spider-Man. Censored hacker. Your favorite hacker in town. Censored hacker signing off. Thank you so much. Have a great night, great evening, and a great day. Love you, and a big bye. Bye, everyone. Have a good one.